Hello and welcome back to part 2 of our last screencast for this unit. We're going to have a really quick screencast here, just going over the different types of inheritance that we might actually be representing in a pedigree. So there are two ways of classifying inheritance. The first way is related to the chromosome that you find the gene on. So there are two types of chromosomes in our cells. There are autosomes and then there are our sex chromosomes. So if you're looking at how a trait is being inherited and the gene for that trait is on an autosome, then we say that it is autosomal inheritance. So autosomal inheritance is when the gene is found on an autosome, and there is also going to be no connection to sex when you're talking about inheritance. So with autosomal inheritance, it's not a case of guys get it more than girls or the other way around. That won't happen because it's just on an autosome. It's not connected to sex in any way. On the other hand, if you are looking at a gene that is on either the X or the Y, we call it sex-linked. Sometimes you can get more specific and you can actually say X-linked or Y-linked if you know which chromosome it's on and you want to be specific like that. When you're talking about these sorts of genes, the inheritance will actually be connected to sex in certain ways. For example, if the gene is on a Y chromosome, it will only ever affect males. If it is on the X chromosome, even though both genders get at least one X chromosome, it can affect them differently. So you can have certain traits that are more likely to affect males than they are females, and some that can be the other way around. Now, if you're talking about a trait that is X-linked, you will actually see it written more like this. Instead of just a capital or a lowercase to represent dominant or recessive, you actually have to represent that it's also on the X chromosome. So you do a big X, and then as a superscripted letter, you do either your big A or a little a or whatever letter you're using. It doesn't have to be an A. And so that's how you represent it. So whether or not the X has the dominant version or the X has the recessive version, this is how we write it. So that is the first type of inheritance. It's based on chromosome type, and you either get autosomal inheritance or sex-linked inheritance. The next type of inheritance is something you're familiar with already. It's just relating to the dominance of the phenotype. So obviously dominant is where we're talking about traits that are dominant. If there's one of their alleles present, that trait will be expressed. If it's recessive, then that trait's only going to be expressed if it's the only allele present. So you should be familiar with all this from earlier in this unit. It's just the same dominant and recessive that we've been talking about the whole time. So you can also classify a trait based on if it's dominant or recessive. So what these two different ways of categorizing traits mean is that overall there are 4 different modes of inheritance, or 4 different ways traits are inherited. So the first would be if you have a trait that's on an autosome and it is also a dominant trait. We would call it autosomal dominant. The next would be if it's still on that autosome but it's a recessive trait, then it's autosomal recessive. Alright, so these are the ones we've kind of been thinking about already when we've talked about dominant and recessive. We've not made any connections to sex or gender, and that's very much what autosomal sorts of traits are. And obviously you can have dominant or recessive, and so you can classify something as either autosomal dominant or autosomal recessive. Now, if it is actually on one of the sex chromosomes, then you actually change that first word to sex-linked, or X-linked if it's on the X chromosome, Y-linked if it's on the Y. Now, we might say X-linked or sex-linked dominant, and we might also say X-linked or sex-linked recessive. It's the same idea. This time we're just saying, okay, it's a dominant trait that's on the X chromosome, or it's a recessive trait on the X chromosome. So those are the other 2 types. Any trait you come across will fit into one of these 4 categories. The only exception to this is going to be Y-linked traits. They're a little bit different, and we'll look at them in a moment. What you can see down the bottom here is just how these sorts of traits can be inherited differently and how parents can pass them on slightly differently. And you will see here with anything X-linked that the X and the Y chromosome are very important when it comes to how things are passed on. And the other thing you'd need to consider is that your offspring, their gender is part of their phenotype. So it's not just whether or not they're a carrier, normal or affected, it's also whether or not they're male or female. So while we can say sex-linked and mean both X and Y-linked traits, Y-linked traits are a little bit different from X-linked traits. Because there's only ever one Y chromosome, we don't worry about dominant and recessive. So you really only ever have X-linked dominant and X-linked recessive traits. With Y-linked, you would just say that the trait is Y-linked. Dominant and recessive doesn't matter because it's never competing with another copy of those genes, because there shouldn't be another Y chromosome. So X-linked is another type of sex-linked inheritance. It will only ever affect males, and there's only ever one copy of the gene present. So as I was saying, you don't need to say dominant recessive. So that is it for different types of trait inheritance, and we'll come back in the next one and go over how to analyze pedigrees. So I'll see you then. Bye.